last chapter you guys studied last year in baby chem was organic chemistry. And it was the last like 2 weeks of school, so I thought I'd start back up with what you learned last year. So I'm going to go over a little bit of organic chemistry that you should have learned last year, but then I'm going to introduce some new stuff, so please pay attention. Okay, organic chemistry is what you know as carbon-based chemistry. We're going to start off nice and easy with hydrocarbons. Hydrocarbons are molecules that have just both carbon and hydrogen. And we're going to start with the easiest, which are alkanes, simple hydrocarbons that have single bonds. Okay, this you should have learned last year. We're going to start with the easiest one. We're going to start off with methane. If you look on the periodic table, carbon has 4 valence electrons. Matter of fact, its hybridization, if you remember this, is sp3. If you remember this shape right here, this is called tetrahedral. Okay? So it has 4 available electrons for bonding. If you bond them to hydrogen here, here, and here, that's the tetrahedral. That's methane, CH4. Okay? That's natural gas. That's the gas that we use in the Bunsen burners. All right. If I take this hydrogen off right here and replace them with another carbon, then it's going to look something like this. So now I've got 2 carbons that are single bonded. This one has 3 hydrogens attached to it. This one has 3 hydrogens attached to it. This is not called methane anymore. It's now called... Uh-oh, what just happened? Ethane. And ethane has the formula C2H6. If I add another one right here, now notice that on the end over here I have CH3, carbon with 3 hydrogens. In the middle I have 2 hydrogens attached to carbon. And then once again I'm on the end over here, so I have 3 hydrogens attached to carbon. So that's 3 carbons and 8 hydrogens. So that's called propane. That's the gas that's in your backyard, hopefully running your propane tank in your barbecue grill. Alright. If I take one more off and add another CH3, it's going to look like this. Now I've got my CH3 on this end, CH3 on this end. This is a CH2, this is a CH2. That's 4 carbons and 10 hydrogens. That's called butane, that you might find in butane lighters. Okay? Now I can continue on. I can take this hydrogen off and add another one, add another one, add another one. I think you get the point. So the next one would be called pentane. Then we have hexane, heptane, octane, nonane, and decane. Now notice that you always take the number of carbons times 2 plus 2. 5 times 2 is 10 plus 2 is 12. 6 times 2 is 12 plus 2 is 14. 7 times 2 is 14 plus 2 is 16. That only works for alkanes. Okay? Alright, what else can I do? Well, since carbon has 4 available electrons, 1 here, and then 2 left over here, I can do double bonds as well. So this 2 carbons bonded together used to be called ethane. With a double bond, it's now going to be called ethene, because any hydrocarbon that has double bonds in it is going to be called not an alkane, but an alkene. And that's where we get that E-N-E ending, alkenes. Okay? The formula for alkenes is going to be whatever the number of carbons is, multiply it by 2, that will be your number of hydrogens. We've got alkanes, we've got alkenes, we've got alkynes. Alkynes have triple bonds. For example, this right here with 1 bond would be called ethane, 2 bonds, ethene, so now it's got 3 bonds, we call it ethyne. If this was propane, it would be called propyne. The pattern for alkynes is you solve for the number of hydrogens by taking the number of carbons times 2 minus 2. Now there's other things we can do, so this is the new stuff, so pay attention. If you have your carbon chain in a continuous cycle, like a cyclo, okay, This is 4 carbons, which is butane. It's in a continuous cycle, so we call it cyclobutane. If it was propane, cyclopropane, cyclopentane, cyclohexane. We can also have substituents. Substituents are just substitutes. If I normally have a hydrogen here, I can take that hydrogen off and replace it with something else that just needs 1 electron. If I replace it with a hydroxide group, then it becomes an alcohol, what we know as alcohols. This right here is ethane. When I attach an alcohol or a hydroxide to it, it becomes an alcohol. It now becomes ethanol, with the OL representing the alcohol. I can replace it with halogens too. Chlorine, fluorine, bromine, iodine, whatever I want. This is 1 carbon, so that's methane. I've attached 1, 2, 3 chlorines to it and 1 fluorine to it. So I'm going to go in alphabetical order, chloro, then fluoro. There's 3 chlorines, so we call it trichloro fluoromethane. This is otherwise known as a CFC. CFCs are found in refrigerants, and they're known for breaking down the ozone layer. Maybe you've heard of them. Okay, here's a new one. If I have an oxygen in the middle of my carbon chain, and let me do this. I like to do little loops around my extra pairs of electrons. I tend to do that in bonding, and so what I like to look to or refer to that as those are my ears for the ether bunny. This is called an ether. When you have an oxygen stuck inside of a carbon chain like this, and you've got your extra pairs of electrons, that's called an ether. This is a methyl, this is a methyl, this is the ether part, so we call it dimethyl ether. If I had an ethyl on this side and a methyl on this side, I would say ethyl, methyl, ether. All right, amines. Amines will have an NH2 attached to it somewhere on there. Okay? A lot of my kids used to say, no haters, don't be a meanie. NHH, no haters, don't be a meanie. Whatever works for you. Okay? So this is the ethyl right here attached to my amine, so we call it ethyl amine. Ketones. Ketones will also have an oxygen just like an ether, but it's going to be coming off of one of the carbons with a double bond, usually in the middle. Okay? So ketones, this is propane right here with a ketone attached to it, ketoned oxygen. So we call it propanone. Propanone. Aldehydes. Formaldehyde, maybe you've heard of that. Have a double bonded oxygen just like a ketone, but it's on the end. You see how on the ketone it was in the middle? If it's on the end, then it's not a ketone, it's an aldehyde. And that's going to have a double bonded oxygen. Look for that hydrogen too. That's also a good indicator that it's an aldehyde. And this will end with an AL ending. So this is ethane, so ethanol. Ethanol. Esters are going to be a combination of a ketone and an ether. See the ether bunny right here? Here's the ether. That's the ketone, right? So this is called an ester. Esters tend to have scents like a banana smell or a wintergreen smell. They're made in the lab. All the candies that you have, if you have banana candy, I'm sorry, it's not made with real bananas. They make this chemical in the lab that smells like bananas. It's a scent. Okay. Sorry, I hear my kids crying. This right here is propane. This right here is an ethane. So we call this ethyl propanoate. The propanoate is the ester. Okay? Ethyl propane, right? Oate, propanoate. Carboxylic acids, or what I like to call coochie coochie coos. Okay, you're going to have a carbon that has an oxygen and a hydroxide. So this is like the alcohol part, right? And this is kind of like the ketone part, or the aldehyde if you want to. Okay, so this right here is your coochie coochie coo. Here's your ethane. Here's the coochie coochie coo. So we're going to call it ethanoic acid, carboxylic acid. Ethanoic acid, it could be propanoic acid, butanoic acid. Okay? Ethanoic acid, carboxylic acids. So carboxylic acids have coochie coochie coos. Esters are a combination of a ketone and an ester. Aldehydes have a double bond on the very end. No haters for the amines. Ketones have double bonds in the very middle. Esters have the ether bunnies ears right there. They're an oxygen in the middle of a carbon chain. We've got cyclos that are connected in a continuous cycle. Halogens, it could be chlorine, bromine, iodine, fluorine. And then the hydroxide group makes it an alcohol. Okay? In class, we're going to go over how to name these. As for right now, you just have to have these kind of memorized, that if it has a hydroxide group, it's an alcohol. You don't have to know how to name them yet. I'll get to that part in class.